Hey guys, we are going to be launching into a new unit. So as we move into our new unit, I want you to know that today we are working in our book. Okay, and so if you're at home, you should have a hard copy of the book that most of your parents picked up. Okay, so if you don't for some reason, you can choose this one right here, the McGraw-Hill icon. It's going to come to this, and basically we are going to chapter 2, and I know this seems weird, we're going to jump to constant rate of change, and I know that seems weird, but I actually need to make sure that I can explain this before I can explain some of the other things that we will be doing. Okay, so this is the first page we're going to be on. It's page 187. Now I'm going to start reading from this, but I did print a copy of this for myself, and it is a horrible nightmare of a mess. It just did not print well. So we'll just have to do our best to figure it out. If you have a book, it's going to be easy to follow along. Okay? So, and if we do this live, then I will just reference my screen instead of this paper. So this says a rate of change is a rate that describes how one quantity changes in relation to another. Okay? So basically you're having two different quantities that are changing. Okay? And it has to be at the same rate, and we're going to talk about that. In some relationships, the rate of change between any two quantities is the same. These relationships have a constant rate of change, so that's what we're going to talk about here. Okay, and we're actually going to talk about two things. We're going to talk about something called a constant rate of change, and we're also going to talk about something that is proportional. So, what you see here says a computer programmer charges customers per line of code written. So this is actually what my brother does. He writes code for people. So he programs, and I think he programs in maybe Visual Basic or C++ or C#. Those are some of the languages. I'm not sure which one he programs, and I think some of you may have heard of something called Java or JavaScript, and I don't know if he programs in that one, but he can basically program in anything. So what he does is he writes lines of code. So our job is to fill in the blanks with how the amounts change between consecutive numbers. So basically we have to figure out 50 to 100, so it gets bigger. So 50 plus what is 100? Okay, and if you don't know that, you would do 100 take away 50. So I'm going to switch over here to my paper, which is going to be kind of hard to read, so I'm sorry, but just know that this is 50, 100, 150, and 200, okay? So between 50 and 100, that is plus 50, right? And then the next one is 100 to 150, and again, if you're looking at your book, you can see this clearly, and you can write in your book, plus 50, okay? And by the way, if you're in your book, you're on page 187, okay? And from here to here, 150 to 200, it is also plus 50, okay? And we're going to talk about this in just a second. So now, this will be lines of code and then the cost. So if the programmer writes 50 lines of code, he gets $1,000. If he writes 100 lines of code, it's $2,000. So I don't know that this is exactly how a payout would look. However, that's what we're doing on this. So basically what they're saying is if you are a programmer and you write 50 lines of code, you get $1,000. If you write 200 lines of code, you get $4,000. Okay? So how much is it from 1,000 to 2,000? 1,000 plus what is 2,000? Hopefully you know 1,000 plus 1,000 is 2,000, and 2,000 plus 1,000 is 3,000, and 3,000 plus 1,000 is 4,000, right? So what we have here is what's called a constant rate of change. For every 50 lines of code, my cost goes up $1,000. For every 50 lines of code, my cost goes up $1,000. Every 50 lines, it goes up $1,000. It is constantly changing by the same amount. Okay? So now here come the two things that I want you to focus on today. One thing I want to make sure you understand is that these are points. We have X and we have Y. Y'all usually see them as something like this. 50, comma, 1,000. And that is something we would graph. Okay? Or you might see it as 100, comma, 2,000. Okay? So these are just points that are on a graph. Okay? So the next thing I want to make sure we know is that in order to find the constant rate of change, this is going to seem upside down to you. Okay? Upside down to you. However, this is how we do it. And we do something really fancy, and we say delta y over delta x. Delta is a little fancy symbol, and it means change. Okay? So as soon as you understand that this little symbol means change, it's okay to say delta y over delta x, okay? But if somebody asks you, you have to know, oh, well, delta just means it's the change, okay? So notice where y is. Y is down here, okay? So how much did y change by each time? Well, that's what this is right here. Each time y changed by $1,000, okay? And then the x value, it changed by 50. So that is my constant rate of change. So we would be reading this as $1,000 per every 50 lines of code, right? This is a correct answer. However, you and I know we like to simplify. So I'm going to kind of do this on the next line just so that we have some room here. 1,000 over 50. What I would do is cross off those zeros. So now I have 100 over 5. So I can divide that, or I can just simplify. I know they both divide by 5. 100 over 5 is 100 divided by 5 is 20. 5 divided by 5 is 1. And I can actually leave it like this if I want to. I know this seems weird, but when you are doing a constant rate of change, you may leave it improper. Okay? You may leave it improper, and there is a reason for that we will be talking about. Okay? So, when you come down here, notice that's what it's showing you. I was just trying to make it where you could see it. Okay? So, we're finding the constant rate of change. So, if I wanted, I could use this to help me go further. I could figure out, if I wanted to, for 250, right? I would just add another 50. And if I add another 50, I would add another 1,000, so that would be 5,000. So that can actually help me. Okay? So I know this seems like a lot of information, but we're going to go over it and over it and over it so much that you're going to learn it. Okay? So the next thing I want you to do is we are going to take this table backwards, and we are going to see if it goes through 0, 0. If it does, then we have a proportional situation, okay? And that's very important for 7th grade, so that you know that, okay? And again, even if you do not understand everything today, we are going to be reviewing this a lot, okay? So I'm going to take my table back. 200 minus 50 is 150. 150 minus 50 is 100. 100 minus 50 is 50. So notice I'm going back 50 each time. 50 minus 50 is 0, correct? And then here it's the same way. I'm going back 1,000 minus 1,000 each time if I'm going backwards. So when I do 1,000 minus 1,000, I get 0. Okay? So it goes through 0, 0. So I want you just to write this down on a sheet of paper right now. If you have a constant rate of change, and we do, because notice it's changing each time by the same amount. It doesn't have to, but if you have a constant rate of change, plus it goes through 0, 0, if it goes through, we call that the origin, then that equals a proportional situation. You have to have both things. You have to have constant rate of change plus 0, 0. You have to have both of those, okay? So, and we're going to be getting into proportional situations soon. But what that means generally is that my graph is going to look something like this, okay? It's going to be linear, and it's going to go through the origin, okay? So that's what proportional means. This table right here tells me that my graph is linear, and that's a new word for you. Notice it looks like the word line, and it goes through 0, 0, okay? So now we're going to do the next one. It says the table shows the number of miles that a plane traveled while in flight. Use the information to determine the approximate constant rate of change in miles per minute. So constant rate of change. So now again, this one's kind of hard for y'all to see. So we're going to go from here to here to here. Now hopefully you can tell this one without showing the work, but if you have to show the work, that's fine. 30 plus what is 60? So if I don't know, I would just show it to the side. Okay, is 30. 90 minus 60, well that's also 30. So each time 120 minus 90 is 30. Each time the time is going up by 30 minutes, okay? Now on the bottom, I have 580 and 290. So let's see, 580 minus 290, 0 minus 0, 8 minus 9 I can't do, so the 8 becomes an 18, and the 5 becomes a 4. 18 minus 9 is 9, and 4 minus 2 is 2. So that went up by 290, okay? So if I was to take a guess, here's the next one. It is, looks like it says 870 minus 580, or that's what we will be subtracting, 870 minus 580, okay, so 0 minus 0, so I can't do 7 minus 8, so it's going to be 17, that becomes a 7, 17 minus 8 is 9, 7 minus 5 is 2, so it looks like, and I'm going to go on and let you know, this one if we subtract, it's also going to be 290, so just so you know, our constant rate of change, delta y over delta x, constant rate of change, delta y over delta x, change in y over change in x. Change in y is 290. That's down here. Remember, it's flip-flopped. And over here, it's 30. Okay? And I can simplify that, right? So my constant rate of change is 29 over 3. 29 miles per every 3 minutes, okay? And if I was to take this back, notice I'm changing by 30 each time, so each time I'm subtracting 30, and if I keep going back by 30, I get 0. Each time here, I'm going backwards by 290, and I would get 0. So what I want you to do on this one is see if you can figure out what the constant rate of change is. Okay? I want you to do that by yourself. Hopefully you can kind of see what my pattern is here.